Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science, just like I did. So today we're going to be covering another additional example from the LeetCode series, so algorithms and data structures. Sticking to Python, the one we have today is Roman to integer, so that's kind of like a Roman numeral to an integer. It's in the easy category, and it's specifically around the topic of strings. So let's get started. The problem statement here within the LeetCode platform is fairly long, but really what they're getting at is an explanation of what a Roman numeral is. So the idea is really you have about, or actually exactly 7 symbols that make up each these equivalent values. So if you're looking at a 1 and a 1 next to it, and we're always reading from right side to left side, that'll be a 2. And then otherwise, for example, this one, 1, all right, we add to it another 1, that's 2. We add to it a 5, according to this, that's 7. We add to it a 10, 17, and then 27. So that's how we get that number. But there is something funny about Roman numerals, which is what I like to call the subtraction rule. And basically, you don't have things like a 1, 1, 1, 1 to make up a 4, but instead you say, give me a 5, and then normally, right, we said right-hand side to left-hand side, and you're going into sort of an increasing order. So you could think of it sort of from top to bottom in this fashion, but all sorts of combination. So if oddly, you get a smaller symbol on the left-hand side, then that's sort of how you get a 4 out of a 5. That's how you get a 9 out of a 10, etc., etc. That's how you get these numbers in that same fashion. And basically, moral of the story, the problem statement, as you may have guessed, you're given one of these sort of long Roman numeral numbers as a string, and then you're turning that into an int. So what I was describing here and sort of how I was going from up and down and right to left is really going to be key here, because of this idea where, as I was thinking about the problem myself, I jotted down a couple of things, 2 examples to make sure that I have us covered with one that has the subtraction rule or not, and then this idea of a previous and current symbol, which I'll later call sort of the right-hand side symbol and the left-hand side symbol. And what I mean by that is, as I'm traversing, this one is the right symbol, the one next to it on the left is the left symbol, and because we're moving from right to left, there's this idea of I need to make sure, am I hitting a subtraction use case, and if so, or subtraction, and if so, then the only way of knowing is really when you get something like this, and by comparing the left-hand side to your right-hand side. What's handy and dandy is you'll see that, one, we're definitely given the fact that we are guaranteed a valid Roman numeral. So for example, I don't think we will get something like an M and then to the left of it a 1, because you'll get, ideally, I guess someone might mean 999 there, but there's other ways of getting to that number. So you won't have things like that. You'll just have these kinds of rules happening. But really, regardless, more generally speaking, you could write very specific code for each of these 3 sets, but really there's this idea of basically if my left-hand side is smaller from a numeric perspective than the right-hand side, then I probably have the subtraction rule. So, there, let's just make sure very, very quickly that this is sort of clear, this idea of how are those 2 examples different. So we've already talked about the first one, but here, this one, you come in through this direction, this is a 5. Okay, great. And then I'm going to add to it a 1, but not really, right? I have a 5, and then this one happens to be greater than what I have on so I'm calling this the right-hand side and the left-hand side. So this is an aha moment, and you're actually going to do 5 minus 4. So now you have -1, and that's a 4, so that's what you have left here. And then you continue going in this direction, and so now you hit a 10. Fine, this is bigger, so you're good to go. You add it to here, you've got your 14, and then you're going to add another 10, and that's 24 in total. So that gives you sort of the full picture of what's happening from a usage perspective. And then we can move to the code, which should be brief in this case. So one thing that we should take advantage of is, I like calling it lookup because we're going to heavily be looking up basically, is, and this is my own code, and but there's plenty of also other solutions out there. So here, I mean, basically, we should take advantage of the fact that we already have these ordered sort of numerics that speak for themselves. And what do I mean by that? We know we're going to start on the right-hand side, or even the example we just did, right? So I personally, I'm sure there, you know, we could sort of try to merge some of this and over here to make it shorter, but I just like having everything out in order for it to be more explainable, but feel free to further adjust. So here, basically I'm saying, well, I guess unfortunately, usually the strings, we would read them, you know, index 0 being this one, the leftmost hand side. So we're going to go on the right hand side. So that gives us the -1. In this case, it gives us this big 1 numeric, and on the otherwise it gives us this V for 5 for that second example. So I'm calling that my right symbol, right? Because we're starting on the right hand side. And then I'm going to use my little handy dandy dictionary to have the value corresponding to that. Why am I saving the value? Because it's going to come in handy when we're going to compare to know if we are doing subtraction or not. So here, I mean, there's cleaner ways of doing this. I believe this might work, where instead you would have a range that's sort of written like this. But basically, you know, for it to be super explicit, you know, -1 is when you're telling it to sort of go backwards. You're asking it to start from basically the right hand side by giving it the length, but because we've already used up you know, the last index here, we're actually going to go length, well, -1, because that will put you outside of the range if you put just len. So that's always a fact, because it's now it's inclusive since you're starting with it this direction, and then we're adding another -1 just so you actually just go in here directly. Since you already took care of the rightmost piece already up there. And then you'd want to stop at -1, and what I mean by that is, right, we're going from this large number, almost, you know, between quotations, length of your thing to get you all the way here, and then you go backwards by 1, 1, 1, 1, 1, and then we do want to get to 0 as the index, so we tell it -1 because always when we do the range, the sort of this side is not inclusive. So when you'll do another going backwards, that'll give you basically 0, because again, you're moving from something like, say here, I don't know, the length is 5, so so it'll be you know, 3 in that case that's remaining, and then 2, and then 1, and then you want to make sure to hit the zeros. That's a long explanation for the range for those that are less familiar with it. But it should be crystal clear, and it's nice to be doing things backwards. So once you have that, right, we already now know the right-hand side. We want to make sure to save the left-hand side symbol, which in this case would be a 1, and in this case would also be a 1. And we grab what it corresponds to, and this is where that little magic of greater or smaller comes into play. So if the right one is bigger, so in this case it's indeed like a 5, and then the left-hand side, however, corresponds to a 1. We are in this case, and that's where we had earlier the little 5 that we crossed out to be 5 minus 1 equals 4. And if it wasn't like the 1, 1, then you just add them up. So now you had the sum equaling that first element on the right-hand side, and now you either minused or plussed, and you're good to go, and that's it. You're ready to move to the one after, so you just update your symbols and values, and it's going to kickstart the next thing out there. And there we go. We can run it with various test cases, and then you could submit it, and it's actually fairly fast. So with that, I will stop us right here, and looking forward to hearing any comments and any suggestions for future videos. And please remember to subscribe. Thank you very much.